oh, it is more than I thought could exist. You move through the room like...
Okay, 3.4 is on applied problems. Usually in this workbook they call it applications. Either way, it's the dreaded word problems. So I will go through some word problems here with you. Obviously I can't do every type, but I'll do some of them and hopefully it'll give you a sense. The first question talks about bearings, so I better remind you what bearings means first of all. So if we're talking about a bearing of north 65 degrees west, do you remember what that means? Well, north, if you're going due north, you have to think of it on a plane here kind of. North, if you're going from this spot, going north would mean straight up. But you're not going due north, you're going 65 degrees west of that. If you're going halfway, like what's the angle that's halfway there? That'd be 45, but we're doing 65, so it should be more than halfway. It should be somewhere down like this. Okay, that's the direction it's going in, like that. So this in here is 65 degrees. That's 65 degrees west of north, and that's what this means here. Okay, just an aside here, let's do one more bearing question just to make sure you understand. If it said south 40 degrees east, where would that be? Well, south would be down here, but you're not going due south. You're going 40 degrees east of it. Hopefully you know your never eat soggy wieners or whatever way you memorize this. So you want to do 40 degrees east, that's this direction. So as I said before, if it was exactly halfway, that'd be 45. So you want just a little bit less than that. That's about the same, isn't it? But anyway, you get the idea. This is 40 degrees. By the way, if this is 40 degrees, how much is this angle here? Well, this one and that one together make a right angle. There's a right angle right there. So this is 50 degrees. Okay? That's bearing. We did it last year and you didn't like it. I don't know if you'll like it anymore this year. Okay, so we've got this first ship. Two ships leave a port. Here's my port right there. Port. At the same time, one sails at 17 kilometers an hour on a bearing of 65 degrees west of north. So there's my 65 degrees west of north. The other sails at 21 kilometers an hour on a bearing of 27 degrees west of north. So it's not going north, it's going a little bit west of north, but it's not going as much. So it wouldn't be this far, it would be something like this, right? And this right here would be 27 degrees. So that's the second boat. How far apart are the two ships after 2 hours? Alright, I'm going to kind of redraw this now. So the first thing I'm going to draw is this red line right there. So I'll try to put it on the same angle. And how long should I make that? Well, this is the first boat, and it says it goes 17 kilometers an hour, and we're doing this for 2 hours. Well, if it goes every hour it goes 17 kilometers an hour, after 2, it would be 34, 2 times 17. So this is 34. This right here is the P for port, right? Then we have this purple line. What the heck, I can draw purple. So I'm going to try to draw that in about the same angle. Now, how far does that one go? It's 21 kilometers an hour, and it also goes for 2 hours. So 21 times 2 is 42. So this should be 42. And now what the question asks is how far apart are the two ships? Use a third color. This is what you want to know. Whoa, that's what you want to know. If we called this angle P here, what's this? This is small p. That's what we have to find. What else do we know? It sure would be nice. Like we have these two angles here. There must be some way we can use those. And there is. Do you see we can actually figure out what this angle is? The angle between the red and the purple there. Since the whole thing is 65, but this little bit in here is 27, if we want to know how much the blue is, what do? You take the whole thing, 65, you subtract the little bit, 27, and you'll be left with the angle, which is 38 degrees. So what kind of situation do we have here? We know a side, we know an angle, and we know the side here, and the angles in between them. This is a side angle side. Now if you remember, you might know which of the two laws you have to use, cosine or sine law. It's the cosine law. But let's say you don't remember that. What you could do, as I told you before, is you try to use the sine law because it's easier. So you look for your pairs. I do have one pair here. I have the angle, and I'm looking for the side across from it. That's good. Now, do you know the angle across from this side? No. Do you know the angle across from this side? No. So you can't do the sine law. So you know you have to use the cosine law. Now, to use the cosine law, it's that formula with a squared plus b squared and all that kind of stuff. But we have p here. So it's fine. You could change your a to a p if you want. Or if that's too confusing, you can go ahead and just change your p here to an a. Want to do that? Why not? We'll make this a and this a. So now I can use, oh, and I guess I should label these. Call one of them b, one of them c. Does not matter which one's which. So the formula I want to use is a squared equals b squared plus c squared minus 2bc times the cosine of a. You don't need to memorize that. I'll give that to you. So a squared equals, b is across from the angle b, so it's 42 squared, plus c is across from angle c, so it's 34 squared, minus 2 times 42 times 34 times the cosine of a, which is 38 degrees. Remember, the way that I recommend you do this is you get this answer, and subtract them. So that's what I'm going to do. But I'm not going to show you my calculator. That's kind of dull. But 42 squared plus 34 squared is 2,920 minus, and if you do all this, 2 times 42 times 34 times cosine of 38, you will get 2,250.6. I know it's not going to be a negative amount because my angle is less than 90. But anyway, you don't have to stress out about that. A squared is going to be equal to 669.4. But of course, if a squared equals that, we need to know what a is equal to, and we would take the square root of 669.4, and you will find that's 25.9 kilometers. And what I like to do is take a look at my picture and see if that kind of makes sense. So this was 42, this was 34, and this is 25.9. That sounds pretty good. Yeah, I think we did a good job there. All right, next one. In triangle ABC, AD is the altitude from A to BC. Angle B, blah, 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 blah. Okay, so what an altitude is when you draw a triangle and you drop a line from the highest point straight down. So it's kind of like the height. So let me draw this a little larger over here. We'll see what we can do. So what we have is, in triangle ABC, AD is the altitude from A down to BC. So here's the altitude straight down. I didn't draw that very well. And there's D. AD is the altitude from A to D. And you know what kind of angle that makes? A right angle. That could be useful later on. Angle B is 48 degrees. Angle C is 32 degrees. And side BC, this whole side here, is 12.8. And we have to find the length of AD. I'm going to call it H for height because that's kind of what it is. It is. So how are we going to do this? Well, first of all, you can see there's three triangles here. There's the whole purple triangle, there's this left-hand triangle, and there's the right-hand triangle. What could you find in the big triangle very, very easily? You could find this angle up here. Why don't we do that? I don't even know if that's going to be useful to us, but why not? Let's try it. How would we get that angle there? Well, those three angles, the A, the B, and the C, add up to 180. So if we do 180, take away the 48, take away the 32, we will get that angle. And that angle is equal to 100 degrees. Angle A is 100 degrees. Okay, so now what could we do here? What you're going to have to do is you're going to have to either figure out this distance, this side length here, or figure out this side length here. Either one will work. And then once you've figured out either one of those side lengths, you can use sine or cos or tan, one of those ratios, to figure out this altitude. So what I think I'm going to do is I'm going to figure out this side right there, that side length. Now, if you look at the whole purple triangle, what do we call that? That's called B. It's across from B. This is side B here. So I always try to use the sine law first. Can we use the sine law to find this? Well, here's one pair. We have an angle B, and the side across from it is what we want to know. And we have this pair too. We have angle A, which is 100 degrees, and the side across from it. So we can use the sine law, and we're looking for a side. So it'd be B over sine B, which is 48 degrees, equals this side length, A, which is 12.8, over sine of A, which is sine 100. And then I cross multiply. So B equals 12.8 times sine 48, and then divide that by sine 100. And if you do that, you're going to get that B is equal to 9.16. Okay, great. So this over here is 9.16, this highlighted bit. Why does that help us? Because if we look at this right triangle right here, that's a right triangle. In fact, what I'm going to do is I'm going to redraw it down here. So here is triangle ADC, or ACD, I guess, it doesn't really matter. And what I know in this triangle is I know it's a right angle here. If it's a right angle on this side, it has to also be a right angle on that side, right? I know this is, I don't know. You cannot just say that this is 50 here. You can't just assume it cuts it in half. It doesn't cut it in half. But I do know this is 32 degrees. I could figure out that angle if I wanted to. If I know these two angles, I could certainly figure out that angle. But I'm just going to leave that for now. I don't think I actually need to know that. I know this side's 9.16, and I want to know this side h. Okay, now look, this is a right angle triangle. You don't need to use the sine law or the cosine law. It actually turns out you could use the sine law here. You could do h over sine 32 equals 9.16 over sine 90. That's okay, you could do it. But hey, let's not forget what we've already learned in this course and what we learned last year. If you have a right angle triangle, you're allowed to use the Pythagorean theorem, although that won't help you here, and you're allowed to use sine or cos or tan, and that will help you here. So let's look from this angle and name the sides we're interested in. Well, the h here is across from the angle, so that's opposite, and this is the hypotenuse. Which one of our ratios is opposite and hypotenuse? It's sine. So what we can say is sine 32 equals the opposite, which is h, over the hypotenuse, which is 9.16. Put over 1 and cross multiply. H equals 9.16 times sine 32, and divide it by 1, which won't make a difference. If you do that, you end up with 5.1 meters. And if I look at that answer, and the sort of numbers we have here, 12.8, 9.16, 5, yeah, it sounds good. So that's that question. Last one. A surveyor in an airplane observes that the angle of depression to 2 points, A and B, on the opposite shores of a lake are 32 and 45 degrees respectively. The distance from the plane to point A is 9,750. What's the width of the lake? Okay, first thing, angle of depression. Here's something else we talked about last year, which you might not remember. So I'll just draw you a little sketch again. If you have, let's say, a triangle, there's two angles of elevation. This is an angle of elevation. I'll put E for elevation. This is an angle of elevation, and the reason for that is because they're between a horizontal and a line of sight. You're looking up, so this is your angle of elevation. If you're looking for an angle of depression, it's not in here. What you have to do is you have to draw a horizontal line, and your angle of depression is in here. There's your D for depression, and there's another angle of depression there. And the reason is because those are again between a horizontal and your line of sight going down. Now, I don't know if you remember this, but what's true about this angle of depression and this angle of elevation? They're the same. We can draw that Z, which you learned way back in grade 9, you might not remember that, and this angle is the same as that angle. Same on this side. This angle here, we can draw a backward Z, and this angle here is the same as that angle there. Okay, very quick reminder of angle of depression. So it says that we have this airplane and it's observing two sides of a lake. There's actually two ways you could answer this. Maybe this is the airplane and here's my lake over here, one side of the lake, other side of the lake, and you're looking to the both sides of the lake like this. But I don't think that's what they mean. We could answer it that way. In fact, sometimes in the book it says there's two answers and you'd have to answer it this way and the way I'm about to show you. But I think what they actually mean in this question is the plane isn't way out here looking, it's in the middle and it's looking at both sides like that. See what the difference is? On the first example, both sides of the lake are on the same side of the plane. But the way I want to answer this question, the plane's in the middle of the lake, kind of. There's one side of the lake to the left of it, one side of the lake to the right of it. I hope that makes sense. It's really not a great question because it doesn't make that clear. And I guess I'd have to answer both of it if I only gave me this question. But I don't want to do that. So here's my plane. And here's the lake. And the angle of depression to opposite shores of the lake. So you look from here to one end of the lake, look from the plane to the other end of the lake, and we're talking about angle of depression. So remember, I have to draw a horizontal line up here. And it says 2 points A and B, so let's call them A and B. And it also says that opposite shores of the lake are 32 degrees and 45 degrees respectively. So to point A, respectively, means in the order they're listed here. So to point A, it's 32 degrees. So the angle of depression when you look down to A is 32 degrees. The angle of depression when you look down to B is 45 degrees. Now remember what I just said? If this is 32 here, how much is angle A? 32. If this is 45 here, how much is angle B? 45. Okay, what our goal is to find the width of the lake. We want to know this distance right here. Well, we've already got an A and a B. Let's call this point up here C. So what we're looking for is little c. How are we going to do that? Well, if we look at the triangle, what can we find very quickly here? We could definitely find the angle right here. Since we have two angles, you can definitely get the third. Or the other way you could look at it is this whole amount right across here is half a circle. So it's 180 degrees. So you could subtract them from 180. Or you could think of it as all the angles in a triangle add to 180, so you also would subtract from 180. It works both ways, which is pretty nice. And if you do that, you will get that the angle is 103 degrees. So this bit here, gosh, I'm running out of colors. This bit here is 103 degrees. So is there anything else we know? Oh, I forgot to put something in here. The distance from the plane to point A is 9,750. Nice. So from point A up to the plane, it's 9,750 meters. This is not too bad because we now have all the information listed here, and we always want to try the sine law. At least I always want to try the sine law first. So do we have our two pairs? Yes, we do. We have the unknown, which pairs up with the 103, so that's a pair. And we have this 45 degrees, which pairs up with the 9,750. So we can definitely use the sine law. And we're looking for a side. So it's going to be c over sine c, which is sine 103, equals b, which is 9,750, over sine b, which is sine 45. Cross multiply. 9,750 times sine 103 divided by sine 45, and if you divide that, you get 13,435.2 meters. You're finished. Kind of surprised we didn't get asked to change this to kilometers. Do you know how to change it to kilometers? How many meters in a kilometer? 1,000. So divide it by 1,000, move it over 3 spots. You get 13.4352, or just 13.4 kilometers. But the question does specifically ask for meters, so you'd stop there. Okay, that's it. I know word problems can be scary, but I believe in you. Go for it.
And the end is unknown, but I think I'm ready as long as you're